Well, here's another one, and I'm sorry if it feels like I'm running through these, but you know we do have another section to cover on this too. You know. All right. So right here, yeah, I'm going to start with the one on the left. So I got to distribute that 5. That's the 5 groups of 1x. That'd give us 5 x's. And then 5 groups of -1 would give us -5 right there. Now we still got the -5, and this is less than 10. And now, even with distribution, we still have some like terms to combine. So let's go ahead and do that. -5 and -5 would be -10. So now it's 5x minus 10, and is less than 10. Well, got to isolate my x's, so let's get rid of that -10 right there by adding 10 to both sides. I'm kind of sticking with the same color here, just because we want to graph it with the same color, right? So I'll drop my 5x. This is less than 20 now. Well, that's a nice inequality to solve. Divide both sides by 5, and the coefficient here is positive, so that will not flip the inequality. Phantom 1x is less than 4, it looks like. And this one does want the interval. I'll try to keep that in mind in the end, even though I guess I did it anyways. This next one on the right. Now you see there's more x's on the right, but they're negatives. So I will, on this one, keep my x's on the left. Okay. So that means, well, I can still do 2 principles of equality in one step here, but I got to get rid of that +6 by subtracting 6 from both sides. That zeroes that out. 14 minus 6 is 8. And also, I'll need to add 6 x's to both sides here, okay? 2 x's plus 6 x's, 8 x's. Oh, this is going to set up very nice again. Coefficient is positive, so I'll divide both sides by that coefficient, 8. And it makes it a little bit smaller. X is now greater than 1. So here's my statement. X is less than 4, or x is greater than 1. This one's gonna give us a bit of a unique scenario, okay? And some of you that have perhaps graphed this already know what I'm talking about. But here we got 0, there's 1, and then 4 over here, something like this. So my 4, at 4, with the red one, that's an open circle because it's not equal to 4. X is not equal to 4 there in red, and it's not eating the x. So this line would go to the left. Some of you may not have drawn the whole thing. Like I said, sometimes students would just draw the line to here and just see what happens with the second one, you know. It's up to you. And then the purple one, x is greater than 1. So at 1, we have another open circle, and it's eating the x, so this one would go to the right. Well, this is an or statement, while the graph is usually what we would expect to see with an and statement, right, with some intersection right there. So again, we could say, look at our interval right here. How far to the left does this thing go? It goes to -infinity. Now be careful because it does not stop at 1. It can just hop between the 2 lines here, but once it gets to 4, even it doesn't stop. It just jump on the purple one and go all the way to the right. So it'd be from -infinity to +infinity. I know I separated those. Hopefully that's okay. Now, what does this mean for our inequality? It just means that instead of writing it like this, we'd have to say that x is, I'd say an element of all real numbers. I'm trying to think how that'd go. X element of all real numbers. Remember that fancy R business? Something like that. It may have you, it should indicate what it wants you to do if it wants the inequality for that on the homework, okay? Like all real numbers, maybe it has multiple choice kind of thing, which I think I've seen in the past. Now, in addition to that, though, the graph, because you wouldn't put 2 graphs on this one for the homework, okay? You'd need to show, since you've done this by pencil now, you see that it goes all the way from left to right, so just do one big line like this. You know, I'll try to make it bigger and prettier. There we go. See, it kind of,
Good.